Good evening, dear students. This is a video for the students who have missed today's class. We are starting a new chapter today. The name of the chapter is chapter number 5, periodic classification of elements. So you all know that what are elements, right? So elements are the purest form of a matter which is made up of only one kind of atoms, right? Now there are so many different kinds of elements around us which make different compounds and the substances that we see around us. So in class 9 we have learned that matter around us is present in the form of elements, compounds and mixtures, and the elements contain atoms of only one type. Do you know how many elements are known till date? At present 114 elements are known to us, but around the year 1800 only 30 elements were known, and all these elements had seemingly different properties. So as these elements were being discovered, scientists gathered more and more information about the properties of these elements. They found it difficult to organize all that was known about the elements. So as the many new elements were discovered, gradually one by one they were being studied. So over time what happened? It was found that the task was not so easy. The task of studying elements one by one was not so easy. They found it difficult to organize all that was known about the elements. So they started looking for some pattern in their properties, on the basis of which they could study such a large number of elements with ease. So what is the necessity for the classification of elements? So it is necessary to classify the elements to make their study easier. Okay. Otherwise, today so many elements are known. If somebody determines to study the elements one by one at a time, studying all the chemical reactions and all, it will take a lifetime. It will take a very long time. So better than it is to classify the elements into groups with similar properties, so that they can be studied easily. And classification also helps in identifying new elements into similar groups. So the next topic throws light into it. That is 5.1, making order out of chaos. Early attempts at the classification of elements. We have been learning how various things or living beings can be classified on the basis of their properties. Even in other situations, we come across instances of organization based on some properties. For example, in a shop, soaps are kept together at one place, while biscuits are kept together elsewhere. Even among soaps, bathing soaps are stacked separately from washing soaps. So this is a very good example given that how classification helps in identification of things. So in our grocery soap, what we find that when we go to a grocery shop, the soaps will be kept together at one place, different kinds of them. Biscuits also different kinds, they will be placed elsewhere. And if it is the shop is dealing with stationery, they will be put in a particular place. So it becomes very easy for a person to sort the things out, sort the things that is required. So similarly, scientists made several attempts to classify elements according to their properties and obtain an orderly arrangement out of chaos. So classification of elements, classification of things prevents chaos, prevents any type of confusion, and makes the study of things easier. Now, the earliest attempt to classify the elements resulted in grouping the then known elements as metals and non-metals. Later, further classifications were tried out as our knowledge of elements and their properties increased. So in this chapter, we will be learning 4 systems of classification. The first one is Dobereiners Triads. 5.1.1 Dobereiners Triads. In the year 1817, Johann Wolfgang Dobereiner, a German chemist, tried to arrange the elements with similar properties into groups. He identified some groups having 3 elements each. So he called these groups as triads. Dobereiner showed that when the 3 elements in a triad were written in the order of increasing atomic masses, the atomic mass of the middle element was roughly the average of the atomic masses of the other two elements. For example, take the triad consisting of lithium, sodium and potassium with the respective atomic masses 6.9 for lithium, 23 for sodium and 39 is the atomic mass of potassium. What is the average of the atomic masses of lithium and potassium? How does this compare with the atomic mass of sodium? So here we are getting 2 points about Dobereiners triads. The first point is that Dobereiners triads are so called because here the elements are classified in groups of 3 elements. Okay, groups of three elements. And second point, important point about Dobereiners triads is that when the elements in a triad were written in the increasing order of their atomic masses, then it is found that the average of the atomic mass of the middle element was found to be average of the other two. So one example that is given here is that lithium, sodium, potassium. So you see lithium, sodium and potassium. This is one of the Dobereiners triad. Triad means a group of 3 elements. So the atomic mass of lithium is 6.9, which is approximately 7. The atomic mass of sodium is 23 and the atomic mass of potassium is 39. Now if we find the average of the atomic mass of the 2 elements on the extremes, what we will get? We should find that the average of these elements should be equal to the atomic mass of the element in the middle of the triad. So we will find out average of lithium and potassium. So lithium is 7, potassium is 39. So average of 2 numbers is divided by 2. 7 plus 39 divided by 2. 7 plus 39 is equal to 46. Okay, divided by 2, and that gives us 23, which is the atomic mass of sodium. So a characteristic features about Dobereiners triads is that in a Dobereiners triad, when the elements are arranged in increasing order of the atomic masses, then the atomic mass of the middle element is roughly the average of the atomic mass of the other 2 elements. So that is the characteristics. Given below in table 5.1 are some groups of 3 elements. These elements are arranged downwards in the increasing order of their atomic masses. Can you find out which of these groups form Dobereiners triads? So in table 5.1, some groups of 3 elements are given with their corresponding atomic masses in the increasing order of atomic mass. We have to find out whether they are triads or not. So let us look at a group A elements. Nitrogen, N for nitrogen, P for phosphorus, AS for arsenic. So atomic mass of nitrogen is 14, phosphorus 31, arsenic 74.9. Now does it form a triad? Does this group of 3 elements form a triad? Now if we look at the value of these atomic masses, it is see, the atomic mass of arsenic is 74.9. Now half of 74 is approximately 37. This clearly indicates that but here it is 31 only. So this clearly indicates that it is not a triad, which means if we go by this proper method to find the average of the this extreme to 74 plus 14 or 75 plus 14 will give us how much? 75 plus 14 will give us 89. 89 divided by 2 will be approximately 44.5, like that, no? So here it is not coming to be 44.5. So this is not a triad. Group A element does not form a triad. But in case of this group B element, calcium, strontium, barium, if we add this to 40.1, 137.3, if we add this to and divide by 2, we will get approximately how much? 137 plus 40 is 177. 177 divided by 2 will be how much approximately? It will give us approximately around 88 or 88.5, which is very close to 87.6. That means this will form a Dobereiners triad. Similarly, here also in the group C elements, chlorine, bromine, iodine. So 35.5 plus 126.9. So here the average of the sum of 35.5 and 126.9 will be approximately 162.4, and the average of these 2 numbers will be roughly about 80 or 81.2, something like that. Okay, 81, 82, like that. So which is, and this value 79.9 is very near to 80, 81. Therefore this will also form a Dobereiners triad. So here among these 3 groups, but here it is quite far away. Here it is coming about 44.5 something, but it is 31 only. It is very far away. So among these three groups, this is not a Dobereiners trait, but these two will be forming Dobereiners traits. So you will find that groups B and C form Dobereiners traits. Okay, Dobereiner could identify only three traits from the elements known at that time. Table 5.2. Hence, this system of classification into traits was not found to be useful. So you see, Dobereiners trait system here. These three Dobereiners traits which he was able to identify were is given here: lithium, sodium, potassium, calcium, strontium, and barium, and chlorine, bromine, and iodine. So you see, this Dobereiners trait is a very simple system of classifying elements, and he did the Johann Wolfgang Dobereiner. He started his pioneering work of classifying elements, but it was not found to be useful because he could not put all the elements known during that time into this system. The Dobereiner could identify only three groups of three traits only. The rest of the elements could not be put into traits. That means they did not follow this system of the average of the middle element. The atomic mass of the middle element is the average of the other two. For all elements, it was not applicable. That is why this system was taken as not useful. So there is some a biography about Dobereiners given here. Johann Wolfgang Dobereiner studied as a pharmacist at Munich, Munzburg in Germany, and then studied chemistry at Strasbourg University. Eventually, he became a professor of chemistry and pharmacy at the University of Jena. Okay, it is the University of Jena. Dobereiner made the first observations on platinum as a catalyst and discovered similar triads of elements, which led to the development of the periodic table of elements. So in our next video, we will discuss about Newland's law of octaves. I hope you have understood what are Dobereiner's triads. So in short recap, according to Dobereiner's triads, elements, Johann Wolfgang Dobereiner, he classified the elements in groups of three elements each, and in which the atomic mass of the middle element was roughly the average of the other two when the elements were in the increasing order of the atomic masses. But then this example is this one. You can write this example of lithium, sodium, and potassium. Okay, but the main drawback of Dobereiner's triads was that Dobereiner could identify only three triads, and all the elements known at that time could not be classified according to this system. Hence, this system of classification of triads was not found to be useful, and that was the limitation of Dobereiner's triads. Thank you.